All right, let's get this thing done. One thing I noticed is that they are putting day 13 in between 11 and 12. I've been kind of wondering why they kept skipping all these spots, and now it seems like they're filling in parts of the puzzle. So I wonder if that means it's related to day 11 or if it's not related to day 11 or what. But hopefully it goes okay. So let's go day 13. Okay, so ferry can make it safely to a nearby port, but it won't get much further. When you call to book another ship, you discover that no ships embark from the port to the nearest airport. Fortunately, a shuttle bus service is available to bring you from the seaport to the airport. Each bus has an ID number that also indicates how often the bus leaves for the airport. Bus schedules are defined based on a timestamp that mentions the number of minutes since some physical reference point in the stamp. Timestamp 0, every bus simultaneously departs from the seaport. After that, each bus travels to the airport and then various other locations, finally returns to the seaport to returning forever. Time this loop takes a particular bus is also its ID number. The bus ID 5 departs from the seaport at timestamps 5, 10, 10, and so on. So the ID 10, when the bus departs, you're going to ride that bus to the airport. Your notes consist of 2 lines. The first line is your estimate of the earliest timestamp you depart on the bus. The second line lists the bus IDs that are in service according to the shuttle company. Entries that show an X must be out of service, so you decide to ignore them. To save time until you arrive, your goal is to figure out the earliest bus you can take to the airport. Exactly one such bus. For example, you have the following notes. Here are the earliest timestamp you could depart, 9:39, and the bus IDs in service are 7, 13, 59, 31, and 19. Airtime stamp 39. These bus IDs depart at the time marked D. Um, uh, the earliest bus you take is bus ID 59. Doesn't depart, so you need to wait 5 minutes for it departs. Multiplying the bus ID by the number of minutes you need to wait for that bus. Okay, so this seems relatively simple. Raw equals this. And let's say line 1, line 2 and so I want to find earliest bus. Multiplying the bus ID by the number of minutes you need to wait gives 295. Earliest bus. And what do I want to call this? Depart int buses is a list of int, and that's going to return an int. Okay, so from typing import list, and bus equals, I want to choose the smallest bus equals min buses, key equals lambda bus, so I want to find so if I do 933 mod 7, I want to this will be 2, so I think it will be 2 things. Bus or let me do it this way. Weight equals bus mod depart for bus in buses. Okay. And no. Oh, I'm tired. Why is this not working for me? So 7 mod 2 so let's say, sorry, missed by, okay, weights equals bus minus miss if miss is bigger than 0, else 0 for miss in missed by. Miss in zip buses and missed by. Okay. And now and it said the buses will have to be unique. So what I'm actually going to do, just to make my life easier, bus minus miss of miss equals L0 for bus. Okay, and bus equals min buses key equals lambda bus weights bus. So choose the bus with the lowest weights and return bus times weights bus. Okay, and so assert, so let me do this. L1, L2 equals raw dot split on new lines, and let's say depart equals int of L1, buses equals int x for x in L2 dot split on commas if x is not equal to lowercase x, and assert that earliest, and it's not really the earliest bus, but depart buses equals 295. So now, I wonder if this is right. It is not right. Okay, so I was worried it wouldn't be right. So let us do this. Let's print missed by and print weights, and then we'll figure it out. Okay, so what did I print? Sorry, I'm having a hard day today. Okay, so buses are that. Missed by are sorry. This should be depart mod bus. Okay, now my assertion worked. So that was the issue. Let's get my puzzle input and put it here. And now let's say raw equals let me just do it this way. Depart equals int of next f, and buses equals I wonder if I can use next like that. We'll see. I don't know if f is an iterator. It probably is. In next f dot split. Okay. And now print earliest bus buses. Depart, comma, buses. 410. Okay, well, let's try it. That's the right answer. Okay, good. The shuttle companies are running a contest. One goal determine they can find the earliest timestamp such that the first bus ID departs at that time and each subsequent listed bus ID departs at that subsequent minute. The first line of your input is no longer relevant. For example, suppose the same list of bus IDs above, and X in the schedule means there are no constraints on what bus IDs might depart at that time. So if the earliest timestamp T such that bus 7 departs at timestamp T, bus ID 13 departs 1 minute after timestamp T, there are no restrictions or requirements. Departures at 2, bus ID 59 equals 5 minutes after timestamp T, there are no requirements. Bus ID 31, the only bus founders are the listed bus IDs. Bus IDs can depart at other times. For example, because blah, blah, blah. The earliest timestamp at which this occurs is 106. Okay. Examples. Some earliest timestamp. So all the listed bus IDs part offset mentioned there. Okay, so we definitely do not want to brute force this. So let us scratch around and think about how we would solve this problem, because this is the first one where just naively writing code isn't going to work. So what we want is find T such that bus ID 7 departs at timestamp T. So T mod 7 equals 0. T mod 13 equals 1. T skip 2, skip 3. T mod 59 equals 4. Skip 5. T mod 31 equals 6. And T mod 19 equals 7. Okay, and I think that's right. So and I can't remember what any of these numbers are. Mod 7, mod 13. No, so that is not true. Equals 13 minus 1 equals 59 minus 4 equals 31 minus 6 and equals 19 minus 7. So this is the same problem as above. So if I mod by 59, I should get 55. Yes, and so on. Okay, so that's what I want. And this seems like the Chinese remainder theorem. And so this is where me being a math person comes in handy. And let's Google it because I don't remember off the top of my head. Chinese remainder theorem says if one knows the remainders of the Euclidean division integer by some integers, one can uniquely determine the remainder of the division by the product of those integers under the condition that the divisors are pairwise coprime. Now, is that really the case? It certainly looks like it is the case because those all appear to be prime numbers. So existence, direct construction. For constructing solutions, non-zero making induction that were moduli just in form computation. N equals I be the product of all moduli plus 1 as the n are pairwise coprime and an I is consider easy to check whether solution search by sieving. So are these numbers all prime? They look like they are. Is 593 prime? Is 593 prime? Yes. Awesome. Chinese remainder theorem, all prime factors. Okay, let's forget about that Chinese remainder theorem. I don't think they actually want us to use that. And if they're all prime, then we can maybe puzzle through this on our own. So let me go back and look at these things. So if I do 7 times 13, so let me look at this one more time. Import math dot product buses, math dot prod of buses is going to be, okay, so that's a big number. I don't want to check all those things. Math dot prod buses divided by 593, that's still a lot. And so let me think about what the right way to do this is. And so so really what I want to do is I want to say buses raw equals x for x in next f dot split on commas if x is not equal to this, and that way I've captured it for x in buses raw. Okay, so now I have and let's say factors equals bus bus minus I plus 1, no, bus minus I for bus for I bus in enumerate buses if bus is equals int bus minus I. So let me just run this again. And look at factors. So that's definitely wrong. Actually, it's okay if I do factors, raw buses, which is a list of strings. And what I want to do is I want to say factors equals this, factors dot append and let's say indexed equals I int bus for I bus in enumerate raw buses if bus is not equal to x, and then factors equals bus bus minus I mod bus. This will just get rid of the 0, I think. For I bus in indexed, return factors. Seriously? $37, 0, 41, 40, 2, 3, 4, 5, 6, 7, 8. So that's definitely wrong. And that's why. Okay. One is 14, and that's because, yes. Okay, so I need the smallest number that mod 37 is 0, mod 41 is 14, mod 433 is 396, and so on. So going back to the Chinese remainder theorem, Python, how about that? Nope, that's not a good one. Let's steal from Rosetta code. If it loads, everyone else is trying to load it too. I don't really understand what it's taking as its inputs. So I think it's just the that looks awful. All right, well, let's copy this and see if it works. I'd love to copy from Rosetta code. So we will put this up top. You know how much I love reduce. And let's say n comma a equals zip star of make factors buses raw. Okay, so that seems right. And now let's do this and say CR mod 37, CR mod 41, CR mod 433. Okay, good. So let's copy this and see if it works. Is this cheating? It probably is cheating, but that's okay. No. Rank 330 in the stars leaderboard. Okay, so that was probably not very satisfying to watch. So what did I do here? The key thing was really this realization that okay, for part one, the key thing was this realization that what I wanted to do was first see how much I missed each bus by, and then compute how long I'd have to wait. And now later I ended up doing it one step. But so you know, I want to depart at time 500, and the bus 7 comes every 7 minutes. So 500 mod 7 tells me, let's say that's 2. That means that multiples of 7, it means that 500 is 2 more than a multiple of 7, and so I missed the bus by 2 minutes. And if it's 0, I missed it by 0 minutes. And then the weights, I just said, you know what, if I missed it by 2 minutes and it comes every 7 minutes, then obviously I have to wait 5 minutes. And I was a little bit fiddly because I wanted to make sure that you can't just subtract it, because if you missed it by 0 minutes, then you don't want to say, okay, then it's 7 minutes away because you missed it by 0 minutes. And then I just said choose the bus with the lowest weights, and it wants to return that product. So that was fine. In part 2, and I'll be clear, I don't like this problem, because if you don't know what I knew, it's probably an impossible problem. And so what I said was bus 7 departs at timestamp t. So in other words, 7 mod t is 0. Bus 13 departs 1 minute after timestamp t. So t mod 7 is 0. Bus ID 13 departs 1 minute after timestamp t. So that means that t mod 13 has to be 12. Meaning that t is 12 more than a multiple of 13, so that 1 minute later bus 13 will come, and then so on and so forth, right? And so you can see I wrote that down as saying I want to find t such that t is a multiple of 7, t is 12, which is 13 minus 1, 12 more than a multiple of 13, so that 1 minute later will be a multiple of 13. T is 4 less than a multiple of 59, so that at t plus 4 it'll be multiple, and so on. And so I said I want to solve these congruences, and then I happen to know, as a math person, that no, that's not what I wanted. I wanted Wikipedia. I happen to know that the Chinese remainder theorem is a theorem about taking a bunch of congruences and finding the number. So it says, if one knows the remainders of the Euclidean division of an integer by several integers, then one can determine uniquely the remainder of the division of n by the product of those integers under the condition that the divisors are pairwise coprime. Well, now, that was why I checked that all the bus times are actually prime numbers themselves. And so in particular, they're relatively prime to each other because they're all prime and all different. And so if that's the case, then, I didn't want that picture either. So I said, based on my inputs, I need to find a number that when you divide by 37, the remainder is 0. When you divide by 41, the remainder is 14. And when you divide by 433, the remainder is 396. Divide by 23, the remainder is 1, and so on. And of course, I don't know. Like, I know the Chinese remainder theorem exists and is relevant, but I don't know off the top of my head how to solve it. And I'm too tired to figure it out. So I said, let's find someone else who has already solved it. And here is, this is not functional. This is, let me go back and say, let me do a little bit of attribution. What is going on here? Chinese remainder code from here. Okay. And so this says that, honestly, I can't make sense of this right now. This is not the code the way I would have written it, but yeah. So good times. Chinese remainder theorem. Anyway, like I said, I don't like this question. And why don't I like this question? I don't like this question because I happen to know that the Chinese remainder theorem is probably relevant here. But if you are not, a math person, maybe you've never heard of the Chinese remainder theorem. And so there's no, without going and doing a lot of research, I don't even know how you would know to solve this. So yeah, I'm, like I said, even though I solved this, still not a fan. Anyway, that's all. Good night. Sleep well. I'll see you tomorrow.